This is the second lesson for section 13.5, which discussed inverse trig functions. This one is going to look at finding angles and solving equations using inverse trig functions. So again, we need to make sure that we pay attention to the sign of the original trig function to figure out which quadrants we need to be in. We're going to take the inverse trig function of the absolute value of n, and then we're going to find the two angles based on that quadrant. This first one, we know what happens at 1/2, the ratio 1/2. We can look to the unit circle for this one if we want to, and we know that theta is equal to pi over 3 or 5 pi over 3. But if we wanted to go through and actually use the calculator, if we've forgotten how to find things on the unit circle, again, first step, we would take the inverse, so we would say we're going to make this alpha instead. Our reference angle is going to be cosine inverse of 1/2. And this is one of the problems with using the calculator, especially with radians. It would work out fine with degrees, but with radians, pi over 3 is not a fun decimal. But you would end up, again, going to your calculator, making sure you're in radian mode. And you would take cosine inverse of 1/2, or you can put 0.5 if you prefer, and you get that 1.047. And just to show you, pi divided by 3 is 1.047. So this comes out to be pi over 3. We know that we've got a positive, so cosine, step 2, cosine of theta is positive in quadrants 1 and 4. So then step 3 is we take quadrant 1. Well, that's just going to be the angle we had, pi over 3. And quadrant 4, theta is just going to be 2 pi minus pi over 3, which is 5 pi over 3. So those are our two angles in this case. And most of the time we are going to end up with two angles, unless of course we're on an axis. In that case, sometimes we only end up with one. This next example, we don't have a nice clean answer that's going to show up on the unit circle. So in this case, we want to solve this equation. We're going to divide both sides by 3 to start off with. Again, just like we do with algebra, we're going to get rid of that coefficient. And we end up with tangent of theta is equal to 1/3. And no, this is not on the unit circle, so we're going to have to go to our calculators. And we're going to say tan inverse of 1/3, and do not use the decimal approximation here, use the fraction. We end up with 0.346. This we're going to use the decimal on, but the 1/3 do not use the decimal on. So 0.346, and we'll go out one more 3. So again, step 1 was to take the inverse. So tan inverse of 1/3 is 0.3463. Second step is to say that tangent of theta is positive. Again, we had a positive ratio here in quadrants 1 and 3. And third step is to take quadrant 1. Theta is just going to be that angle. Again, if you need a reminder here, with our unit circle, we've got 0, we've got pi over 2, we've got pi, and we've got 3 pi over 2. So if you're trying to remember which quadrant you're in, we've got 0, pi over 2 is approximately 1.57, so if you're less than that, you're in quadrant 1. If you're between that and approximately 3.14, then you're in the second quadrant, and if you're between that and approximately 4.71, you're in quadrant 3, and 4.71. 0 is also 2 pi, which is approximately 6.28. So those are the numbers, again, if you're trying to remember which quadrant you're in. In this case, we already have quadrant 1, we're 0.3463. And then we need quadrant 3. So to find in quadrant 3, we are going to add pi 2.346 So again, going back to our calculator, we are going to add pi, and we come out with 3.488. This next example here, we're not actually going to get to a numerical answer. This is just more of a theoretical example to get you guys used to the notation. We want to solve this for x. So likewise before, we're going to divide by that coefficient because the x is over here with cosine. We end up with y over 3 is equal to the cosine of x. And again, we said to get rid of cosine, we're going to use the arc cosine or cosine inverse. So we're going to do that to both sides. And we end up with x being, because again cosine inverse of cosine is just going to get us to x, is going to be cosine inverse of y over 3. So again, there's no numerical answer in this case. We just get things rearranged. We get the inverse function. I want you to pause the video here and try the next example. So again, we're not going to get a numerical answer for this one. We're just going to rearrange. Again, the opposite of arc sine is sine. So you're going to take sine of both sides. You get sine of y then is 5x. Divide both sides by 5, and you get that x is equal to sine of y over 5. And again, part of the reason I work through these is so that you kind of get more familiar with the notation and to, again, recall order of operations, which usually don't involve trig functions, but should. Trig functions, again, are going to be kind of like outermost functions. In this case, or if there's a coefficient, we would deal with that first. Let's look at a few more examples here. This is another one we're not going to get a numerical answer for, but it's good to practice our order of operations. In this case, we're trying to solve for x, so we need to get rid of this outermost function tangent inverse. So we're going to take tangent of both sides, so the tangent of 3y. Again, when we take the tangent of the tan inverse, we're going to get x plus pi. And then we can subtract pi from both sides. And this is where we need to be very careful. Tangent, I'm going to put parentheses of 3y so that we know that that minus pi is not included in the function. So this is our answer. Again, we're not going to get a numerical result out of this. It's just a rearranged formula. Again, I want you to pause the video here and try the next example. So again, be very careful with order of operations here. First thing you're going to do is multiply by 2. Then you're going to take cosine inverse to get rid of that cosine. Again, you're going to put the 2y in parentheses because the next step is to subtract 1. Then you've got to the last step, divide by 3, so you end up with cosine inverse of 2y in parentheses, and then minus 1, and that whole thing is divided by 3. So let's take a look at a few more examples. This next example goes back to kind of what we were looking at before, in that we look at taking cosine of an arc function that's already acting on a ratio. So we've got that ratio of the square root of 3. Again, if you go to your unit circle, you can see that the tan inverse or arctan of radical 3 is pi over 3. Or 4 pi over 3. And then we need to look at taking the cosine of both of these. So cosine of pi over 3 we know is 1/2, and cosine of 4 pi over 3 is negative 1/2. So in this case we end up with two values depending on which one of those outputs the arctan would result in. We don't have any other information about what quadrant we were in to begin with, so we have to go with the fact that there's a possibility of two answers. A few more examples here, and again we're going to go back to solving. If we want to solve the following equation, we've got cosine squared theta minus 0.4 cosine theta minus 0.95. In this case, this is one of those where you want to factor, and if you want to rewrite this, for instance, as x squared minus 0.41x minus 0.95 equals 0. So in this case, we're going to let cosine of theta equal x, just to simplify things, just so we can see that this is really algebraic. Then we go through, this one doesn't factor very well, but we can use the quadratic formula. So x is equal to negative b, which is negative 0.41, plus or minus the square root of b squared, so minus 0.41 squared, minus 4 times a is 1, and c is negative 0.95. All divided by 2 times a is 1 in this case. So in this case, again, putting things into your calculator. Okay, so we have to be very careful about putting this in the calculator if you're trying to do it all at once, which is what I'm going to kind of show you right now. We are going to start off with a parentheses because we've got a whole big thing in the numerator. And then negative, negative, we don't necessarily have to put both those in, so I'm just going to put 0.41. I'm going to start off with the plus, and then I'm going to take the square root of parentheses negative 0.41 squared. Again, that has to be in parentheses or it won't square that negative. Minus 4 times, we don't really have to put the 1, but we can if we want to, times negative 0.95. And so we're going to close this parentheses. That's going to close the square root. We're also going to close the top parentheses because we're done with the numerator. Then we're going to divide by 2. And you could put times 1 there, but we really don't have to right now. And we're going to hit enter, and we end up with 1.2. So this is one of our answers, so let's write that down. We can take it out a few more decimal places, 201. And then, again, the nice feature of this calculator is if you hit second entry, you get the same thing. So now all we have to do is kind of scroll back to where that plus was and change it to a minus to get our minus here, and hit enter, and we get negative 0.791. Again, you have to be very careful here with how you put things in. You're more than welcome to do it in steps if you prefer. And again here, this is not the answers. These are not the answers. These are what cosine of theta is equal to. Because again, remember, x is equal to cosine. So cosine of theta is equal to 1.201, or cosine of theta is equal to negative 0.791. Now, if you try to put this first one and do cosine inverse in your calculator, you're more than likely going to get an error message, and you should, because if you remember, when you're graphing cosine, it bounces up and down between negative 1 and 1. It's only going to oscillate between negative 1 and 1, so cosine can never be bigger than 1 in magnitude. This one, on the other hand, is going to be fine. We've got cosine theta equals negative 0.791, and we're going to take the inverse cosine, so theta is going to be cosine inverse. Again, going back to the rules we had at the beginning of this section, we don't look at the negative at first. We say 0.791, and we get our reference angle. So cosine inverse of 0.791, we get 0.6584, and again, this is in radians. And then we say, okay, cosine is negative in quadrants 2 and quadrant 3. So we'll look at quadrant 2, and in that case we're going to take pi minus our 0.6584, and that is going to come out to be, so pi minus our answer, and we get 2.483. And if we go to quadrant 3, so that's one of our answers. If we go to quadrant 3, we get pi plus 0.6584. And we've got, then we're going to have to put this one in manually, pi plus 0.6584. And we get about 3.8. Again, you got that 0.99999, so we're just going to round that up to 3.8 radians. So that's our second angle. So again, go back. This is a lot of steps for this problem, but that's okay. Again, we had to kind of go through, rearrange it, and do some algebra here. Then we got to the trig part and did the inverse, and we ended up with 2 angles in this case. So we've got one more example here. This one's a little bit cleaner. We've got 2 cosine of 3x minus 1 is equal to 1. So first things first, just like in algebra, we are going to divide both sides by 2. And then we're going to end up with cosine of 3x minus 1 equals 1/2. So at this point we need to get rid of cosine, so you can either do cosine inverse or look at the unit circle. So we end up with 3x minus 1 would be cosine inverse of 1/2. Again, cosine ends up being 1/2 at pi over 3 or 5 pi over 3. And so now we have 2 separate equations that we need to look at. So we've got 3x minus 1 is either equal to pi over 3 or 3x minus 1 is equal to 5 pi over 3. And again, we need to solve both of these equations. So we're going to add 1 to both sides, so we end up with 3x is equal to pi over 3 plus 1. And then finally, we're going to divide both sides by 3, and we end up with x is equal to pi. If we want to combine this into one fraction, we end up with pi plus 3 over 3 over 3, or if you simplify that, pi plus 3 over 9. So this is one of our answers. I want you to pause the video here and see if you can solve the other equation. And so for this one, you should have ended up with x being 5 pi plus 3 over 9. So this concludes the video for section 13.5.